A company claims that a quarter of the bowls sent to them are faulty. To test this claim, the number of faulty bowls in a random sample of 50. Okay, so 50 is the random sample, so obviously this is going to be binomial. Okay. Give two reasons why a binomial distribution may be a suitable model for this faulty bowls in a sample. That means the properties of the binomial distribution. So there are two outcomes, faulty or non-faulty bowls. This is one of the properties, and the other property is the number of trials are fixed. So the number of faulty bowls are fixed. Faulty bowls are fixed. So that's it. But remember, you need to give the sum in context, otherwise there will be no points given. Okay, using a 5% significant level, find the critical region for two-tailed test of hypothesis that the probability of a bolt being faulty is 1/4. So the probability of bolt being faulty is given. The probability of rejection in either tail should be close to as possible 0.025. Okay, it is critical region, meaning hypothesis test. So H0 probability is 1/4, they have given. H1 probability, this is critical region two-tailed. Two-tailed means not equals to 1/4. So the distribution is going to be x equals to number of successes, that means number of faulty bolts, and the distribution would be n is 50 and p is 1/4. So 50 1/4. 1/4 is 0.25. Okay, so we want to find the critical region. So here, if this is critical region C1 and this is critical region C2, so less than probability is 0.025 and greater than probability is 0.025. That means significant level, if you add it up, 0.05 or 5%. So one of the critical region is x is less than or equals to critical region 1 is equals to 0.025, and x is greater than or equals to critical region 2 is 0.025. So we have to find the value of C1. So we need to look up the binomial table. This is the binomial distribution table where n is 50 and p is 0.25. So when we look under, we are looking for 0.025. So we don't have 0.025. The closest is 0.01 because 0.04 is farther away. This is 0.01. So we're looking for the random variable C1. So this is 6. So that means for probability of x is less than or equals to 6, this is equals to 0.0194. Therefore C1 is equals to 6. Then for the other one, we need greater than or equals to C2. So we can write probability of x is greater than or equals to C2 equals to 0.025. Since this is discrete, it would be 1 minus probability of x is less than or equals to C2 minus 1. Remember, in discrete always 1 becomes less. So 0.025, if we just shift the side, it would be x is less than or equals to C2 minus 1 minus 0.025, which means 0.975. So in the table 0.975, the closest is 0.9713. 0.975 means 0.9750. So this is the closest, and we have 18 as a random variable. So therefore probability of x is less than or equals to 18 is 0.9713. 0.9713, yes. So that means, so C C2 minus 1 is 18, therefore C2 is going to be 18 plus 1, 19. So the question was it about significant level, was it about critical value or critical region? They said critical region, so we have to write it as a region. So x is less than or equal to, so x is less than or equals to C1, so which is 6, or x is greater than or equals to C2, which is 19. So the next question is find the actual significance level. So this is question number C. So the actual significance level is going to be probability of x is less than or equals to critical level 1, critical region 1, x is greater than or equals to critical region 2. So this is going to be less than or equals to 6. We found it out. Less than or equal to 6 is 0.0194. So 0.0194 plus greater than or equals to 19 is 1 minus probability of x is less than or equals to 18. So let's put in the values. 0.0194 plus 1 minus, this is going to be 0.9713. Obviously it is going to be closer to 5%. So this is the actual significance level. Next, in the sample of 50, the actual number of faulty bolts was 8. So in this question, this is actually a common question with critical region. So if it is 8, now 8 does not fall in the critical region. If it is 6, less than or equals to 6 and greater than or equals to 19, 8 is somewhere around here. It does not fall in the critical region, so 8 is not in the critical region. So if it is not in the critical region, it is not significant. If it is not significant, we have to accept H naught. So what was H naught? What was the context? The context was the company said something. The company claims that a quarter, meaning 1/4 of the bolts sent to this are faulty. So the company's claim is correct. So because the challenge was for the two-tailed test, so that is not going to work. So company's claim is correct. Company's claim is correct. The machine making the bolts was reset and another sample of 50 bolt, okay, we have a new sum of 50 bolts was taken. Only 5 were found to be faulty. Remember, this is the random variable is given. So test at 1% level of significance whether or not the probability of a faulty bolt has decreased. State your hypothesis clearly. So we have to do the sum again. Another hypothesis testing. So H naught is the same, 1/4. H1 is decreased. We want to test distribution. We have defined it before, x, so that is fine. So binomial distribution is 50, 0.25. 1/4 means 0.25. So the probability we need to test with random variable. So here our random variable is only 5 were found to be faulty. Since random variable is number of faulty bolts, so only 5. So that means random variable has to match with the alternate hypothesis. So x is less than or equals to 5. We look up the table and this is, so 1% is the significant level, so this is significant. It is significant. If it is significant, reject H naught. Now we have to give the context, and the context is the faulty bolts has decreased